So here it has been asked to find the image of the point having the position vector. Suppose we take the point A. So this point is having the position vector. Suppose this is the origin. So here OA vector, which is the A vector, that is given as I cap plus 3j cap plus 4k cap. So therefore the coordinates of the point A will be 1, 3, 4. So now we have to find the image of this point in this plane, which is given. The equation of the plane pi1 is given as r vector dot 2 I cap minus j cap plus k cap, that is equal to plus 3, that is equal to 0. So therefore the image will be, suppose a dash. We have to find the coordinates of the point a dash, and also the position vector b vector, which is o a dash. That also we have to find. So b o a dash is the image of the point p, image of the point p with respect to this plane pi1. Sorry, it is the image of the point a with respect to this plane pi1. So let's say the straight line joining the object and the image, it intersects the plane at the point M. So therefore, we know that a dash, uh, the straight line a dash or the vector a dash should be perpendicular to the plane, should be perpendicular to the plane pi1. So and also the point M, which lies on the plane M, is the foot of the perpendicular. M is the foot of the perpendicular on the plane pi1 from the point A. And this M should be the midpoint of A and A dash. M should be the midpoint. M should be the midpoint of A and A dash. Since why? Since since we know that the object distance should be equal to the image distance. Object distance from the plane, that should be equal to the image distance from the plane. So it means the point which lies on the plane and which connects the object and the image, that should be the midpoint of A and A dash. So now let us take the image. Let us take the image A dash as, suppose, x1 comma y1 comma z1. So that we need to find actually. So therefore, since a dash vector, that is perpendicular to the plane pi1, therefore the normal vector n1 vector, which is the normal vector to the plane pi1, so it means n1 vector will be 2 I cap minus j cap plus k cap, obviously. So now a dash vector is perpendicular to the plane pi1, so a dash vector should be is parallel to a dash vector should be parallel to the normal vector n1. So therefore I can tell a dash vector, that should be equal to some lambda times n1 vector. So now a dash vector, if I consider it as x1 y1 z1, then a dash vector will be x1 minus 1 I cap. Since why a dash vector is nothing but o a dash vector minus o a vector. O a vector. So it is obviously x1 minus 1 I cap plus x2 minus 3 j cap plus, no, it is y1 minus 3 j cap and z1 minus 4 k cap. And that should be equal to lambda times this n1 vector, which is 2 I cap minus j cap plus k cap. Okay. So if we compare both sides. Therefore we can get that x1 minus 1 that is equal to 2 lambda. It means x1 equal to 2 lambda plus 1, and y2 y1 that y1 minus 3 that is equal to minus lambda. So y1 equals to 3 minus lambda, and z1 minus 4 that is equal to lambda. Therefore we can say that z1 equals to lambda plus 4. So therefore the point a1 the point therefore the point a dash can be taken as 2 lambda plus 1 comma 3 minus lambda comma lambda plus 4, and the point a is obviously given as 1 comma 3 comma 4, and the point m is the midpoint. M is the midpoint of a and a dash. So therefore the coordinates of the midpoint, therefore the coordinates of the point a, coordinates of the point m, that will be obviously x1 plus x2 by 2, which is 2 lambda plus 1 plus 1 by 2, comma 3 minus lambda plus 3 by 2, and comma lambda plus 4 by 2. So that will be equal to so that will be lambda plus 1. This will be 6 by 2, that is 3 minus lambda by 2, and this will be lambda by 2 plus 4. Okay. So, and this point M is lying on the plane pi 1, so it should satisfy the equation of the plane. So now we can tell, since the point M lies on the plane pi 1, so it should satisfy the equation of the plane. So it should satisfy the equation of the plane. So therefore, the point M, which is lambda plus 1, comma, it will be 3 minus lambda by 2, comma, so it will be lambda by 2 plus 4. So therefore, the position vector of the point M we have to find. Therefore, the position vector of the point M, OM vector, that will be obviously lambda plus 1 I cap plus 3 minus lambda by 2 j cap plus lambda by 2 plus 4 k cap. So this we should consider it as the R vector, which is the position vector of the point M, and that should satisfy the equation of this plane. So if we put that as R vector, then we will get that lambda plus 1 I cap plus 3 minus lambda by 2 j cap plus lambda by 2 plus 4 k cap. Then we have to take the dot product with this, which is given as 2i minus j plus k, 2i minus j plus k, that is equal to so that plus 3, that is equal to 0. So therefore we can tell this will be 2 into lambda plus 1, then minus 1 into 3 minus lambda by 2, then plus 1 into lambda by 2 plus 4 plus 3, that is equal to 0. So then we will get 2 lambda plus 2 minus 3 plus lambda by 2, then plus lambda by 2 plus 4 plus 3, that is equal to 0. So then we will get, this is 2 lambda plus lambda, that is 3 lambda, 3 lambda. So 3 and 3 will get cancelled, and this will be 3 lambda plus 6, that is equal to 0. So 3 lambda equal to minus 6, then lambda will be equal to minus 2. So therefore, if we put lambda equal to minus 2, then we will get the point, the image point, which is A dash. So now, therefore, the point A dash, that is given as 2 lambda plus 1, 2 lambda plus 1, comma 3 minus lambda, comma lambda plus 4. So that will be equivalent to, if we put lambda equal to -2 there, this will be -4 plus 1, then comma, this will be 3 minus lambda, so it is +2, then lambda plus 4. So this will be equal to -3, 5, 2. So this is the required, image. This is the required image of the given point, which is 1, 3, 4 with respect to this plane of the given point, we can tell. And if we want the position vector of the image, that will be O A dash vector. So that will be -3i cap plus 5j cap plus 2k cap. This also we can write as the answer. Okay, thank you.